ground satellite testing and operation as one site meeting. My name is Kateryna. I'm product manager at Leanspace, and I will be your moderator for this session. And I'm accompanied by Roberto, who is also a product manager at Leanspace, and he will be mostly executing the demo, and we also have our partners from Exotrail, Leanspace, and our friends from AWS. And yeah, we'll also have a joint demo with Exotrail and Leanspace. So yeah, I think we can start. So today in the current market, when we are starting to procure ground segments, the problems that we see customers have are the following. So basically, you're trying to pick a system. You have multiple systems around. You have the testing system. You have your C2 system. You have mission planning. You have flight dynamics. You have the ground station providers. And in general, it's like all separate, all over the place, and they don't necessarily work together well. Which leads finally to the fact that you need to put in place all the interfaces, connecting all the systems. But yeah, you put it for your first satellite, it kind of works, then it works on ground, then satellite flies, and it breaks. So you need to put all the interfaces again, which leads to rework, redevelopment, increase of the cost. There are huge risks, You spend already a lot of money. You definitely don't want to spend money again. Also, then you get your second satellite. So you try to get it in the system. And what happens then, it probably doesn't scale. That's really big problem because, compared the system, you was hoping that it will work well, and it doesn't. So now you need to go and find something else, or again, do some more development, which adds more problems, more communication issues, and again, like more development time, more money spending. And you're already kind of running out of it, so you would prefer to spend it elsewhere. And yeah, it also leads to low efficiency and delayed decision making because you're spending time not on your mission, you're spending time on connecting on the systems. So what would be actually great is have something that works together out of the box.
So we have in Leanspace, we have a cloud platform. The idea is we have one cloud platform that you can use testing to operation. Because when you think about it, when you're planning your test on the ground or executing it or analyzing it, it's not that different from when you're planning procedure or when you're executing procedures. So of course there are small differences, but we believe that the small differences doesn't make it worth to set up a new tool, to have two completely different tools. But then when you have two tools, two setups, two engineers, and to double the work for the configurations, then it's space that the tools are not synchronized, and that's why we do this.
Let's see how it looks more in details.
So this is a very simplified architecture. This is the philosophy behind Leanspace. So we have a cloud platform, cloud native on AWS, and the platform provides APIs that can be used by applications, and applications can be anything. Because the cloud platform has APIs, again, can be like scrapes, APIs, can be front-end applications, like I'm going to show you today. And then finally, this API-first approach is going to make it much easier to do integrations with benches, ground stations, or third-party users. And in addition, we also provide some of this integration natively out of the box. So in this way, we only have to configure one cloud platform instead of configuring, for example, 3 different applications. So let's take a look inside what's actually inside our cloud. So for example, we have terms and performance. It means, first of all, you have to set up your dependency chain. And the idea is, when you're doing testing, for example, you're doing functional testing, you still need to set up the dependency chain. Maybe it's going to go to the military instead of the radio. One part of it is going to be the same, so there is no point in redoing the work twice. And then in Leanspace, you can set up your digital models and insert the model in your assets. And these assets then are used by all your applications. So there won't be any mix-up in the future when the avionics team is going to call your reaction wheels 0, 1, and 4, and the operations team are going to call them X, Y, and Z. So this is going to streamline a lot. And the real bug is that once you have a lot of satellite, things can become very complex and very confusing. And then of course you have other things like logs, where you can log, for example, test when you're testing the ground, you can log your conditioning, you want to read them as test maybe, and then you promise to set all the actions that are available in the investment form. And then finally, get the integrations, as I mentioned before, with test benches, SmallSat, and with these services and so on.
So that was like a high-level overview of our platform. And for the second part of our site meeting, to make it more relatable to you, I will be impersonating a future satellite operator. And Roberto is my fellow ground segment provider, ground segment software provider. So just to let you a little bit of the details, my company, we're launching an EO satellite, and we'll have also some additional payloads to test it. And yeah, we've ordered our systems. It's on the way. We're actually going to receive our SmallSat soon, to do all the general system testing. And yeah, Roberto.
Then
Can Leanspace actually help me with testing my satellite?
Yeah, then just a moment later, there's the SmallSat. Just received it. And if you work in the past, when you're receiving a post-sat, SmallSat is probably going to miss parts. So you still want to test it, at least what you receive and see if it works. So, as I showed you before, we start with the full infrastructure. You're going to see this diagram a lot during this presentation. And what we're going to do is leverage part of the platform to utilize an application. So here we're going to talk about the testing part. So the things that you want to do for testing is tendency chain, and it can be like tendency chain for the satellite, it can be like connected to the test benches and operating them. Of course logs, because you want to generate reports from your test. And then, as always, you will have the digital models that are going to be utilized by the platform. And finally, you will be having integrations with the test benches. It can be test benches, it can be SmallSat, Villat, and so on. So now, what I'm going to show you is an example applications that we did for the test light. And the goal of this application is to visualize and analyze the data. And the power of the application itself is thanks to the Leanspace services. Because it's a Leanspace services that are going to store everything in test records, and then the application is just leveraging that to show it, to organize it, and to share it with other teams.
So all the setup is happening in the platform. It's an application that just follow things. Is that right?
Yes. So for the test light, for example, here we're looking on the left, we have all the digital assets of the model. In this case, we have 2 satellites, we have some test equipment, and constellation. But of course, this is nothing new. The cool thing is that all the digital models that you see here, we keep seeing them through the presentation and different things. And then, in this case, in the example, we run some test cases. So, for example, you can see in here that we have run some tests, and we can have a look maybe at this material charge. So, first of all, I zoom a lot the text so everyone can read, but of course, when you have text on display, you can zoom out, and then it's going to be perfect. So, here we are getting all the information from the platform. So, we can see we are storing some properties. So, for example, you will know which software version you use when you run the test. You will know who will perform the test. These are kind of information that sometimes can be lost. and it's good to have all of them in one place, in one cloud cluster. Then here you can see the digital assets, then we have associated metrics or telemetry points that are relevant for the specific test. And then, when you have the test, you want to see all the telemetry or telecom targets that you send. Then finally, you can have comments, say that there's something was wrong, or if there's anything that you want to clear changes that you can test. And then, finally, what we want to also enable is because you have all the tests in one place on the platform, you are able to visualize, for example, two tests at the same time, to compare the data. So we saw if all tests were some issues and failed. So let's compare it with the first test that we ran. And then, for example, you can visualize them both at the same time and see, okay, here there was a spike for the temperature, maybe it was a false alarm to commit the test. So as I said, the power of the application is leverage the cloud platform. So all this data that was going to be used during cloud testing is going to be available also in production.
Hardware testing, it's of course cool, but I'm really scared of the connectivity with the ground stations, and I really don't want to have all this overhead development if something doesn't work out. So
exactly. So we were working with testing, with the SmallSat, and we, of course, when you have a SmallSat, it's easy to check if it works. A bit there, maybe you fight a little bit with the flash software to have a little bit SmallSat, but you can test. And then, once you have an orbit, you need to be sure that it's going to work. For this reason, instead of connect with the test benches, we will have to connect with the ground station. So, for this example, we have integration with ground station providers, and we're going to show you, we're going to talk about the integration with Leanspace, and we have a special guest, Berenger, who's going to come and explain to you how to make sure that you will be able to talk with your software once it's available.
Thanks, Roberto. Hi everyone, thanks for being here. Villat, Director of Delivery in Leanspace. I will show you quickly how we handle the integration and the onboarding of our customer. Usually, after a contract signature, we start with a initial integration kickoff, which is a small meeting that is setting up the different activities for the integration with the customer. Then we'll go ahead with the RF integration in case we have a radio that we're supporting. In that case, we will need you to either send us a radio or we will send you some equipment that we can do some testing and some integration with you. And after that, we will also do a formal RF test campaign that we can also do with IQ recording, for example. In the case that it's a radio that we're already supporting, you just need to send us this file, any radio configuration. We will replay them in our laboratory and verify the configuration. Then we will do the same for the uplink, in which we will send you some uplink file that you will replay to the SmallSat, and you will be able also here to validate it. In parallel to that, usually our customers need to also integrate with our interface. So these are our API and TMTC data connection and data interfaces. In the case of Leanspace, this is already done, so we have nothing to do here. So that's that. We can proceed basically. And so usually that full process here that we are seeing takes between 1 and 6 months. If we are using a radio that we are already supporting, that can go to even a week. Once all these these two parts are done, we can move forward to the end-to-end testing. That's where we start working with Leanspace directly. We put everything together, so we will replay the IQ that you provided to us, and we will be streaming the data directly to the Leanspace platform. We will also be creating some test contacts that we will be able to retrieve directly from the Leanspace platform, and that way we'll be able to validate the full integration between the ground segment network from Leanspace and the platform from Once this is validated, that gives you access basically to the full network, since we have a fully standardized network of ground station. Once you validate it with one of our systems, then technically you are able to use any of these ground stations from the network. Obviously, there are other parameters to take into account here, which are, for example, the licenses, but from the technical point of view, you have access to everything. And the great thing with this standardization model is that if we are installing new ground station, there will be already operating for you. You will be able directly to use them for your mission. And to also build up on what Kateryna was saying before, if you are building a newer satellite and you're using the same hardware and radio configuration, most probably we won't need to rerun another testing campaign because if the configuration is exactly the same for us, it would just be like adding a satellite in the database and you'll be good to go and you'll be able to use our network.
Another question, when you say ground station, you mean antennas? Is it correct?
Yes.
Just for the general information, we'll have a Q&A session at the end, so
Sorry.
no worries.
Okay.
And depending on the model.
No, I had a similar discussion in February in Malaga. We call it different, but
yes.
I feel we're doing great.
We mentioned it as location for the site and on the site fix.
It's great.
Super. Thank you very much. So I hope you're all sure that you will be able to do the satellite.
Well, yeah, now I know that I can test it. But, operations part, how is it working? Because it seems, you show that it's modular, cloud, all fancy and modern, but yeah, we need to put all the new interfaces again. Like we just put all the TMTC chip, we just check the connectivity. And now, FlatSat and RealSat, it's not the same sat. Well, it's kind of the same, but it's two different entities still. So, yeah.
So, we'll be testing the links weekly. It's, sorry and so what we test in the lead is the actual telemetry chain, the same way that it's going to work in orbit. So the telemetry chain that we start building when we'll be testing on ground with the FlatSat, we added the delta to perform the end-to-end testing in the lead. Now, what that's left is going to orbit.
Yeah! So happy.
So as you said before, you were using the telemetry chain, logs additional models, we're coming to the test benches, and we will be using the testing applications. Now we can use the MCS application for some employee C2, command control, etc. So we are using the same blocks that we're using for testing, and we are running monitoring and some applications too. So now I'm going to show you the MCS live. This is an example application that we built to show how to leverage the cloud services came into this. So first of all, and I don't want to impress you with the MCS, you've seen them multiple times. So in a simple MCS, you have some commands that you can send manually, you have some telemetry that you can do, and then of course you can see the history of the commands. But what is important to note here is that it's not the ability to send commands or the ability to see the directory. It's that these are the same commands that you were sending in your testing application. So the names are the same, the metrics, these are the same metrics that you were sending, you were looking at when you were performing your test. So there's a lot of continuity. And then, for example, I showed you the testing application before. You can use a testing application to compare the test on the ground and the test on the orbit. And then you can see dashboards where you can visualize the behavior of your satellite, because you're going to have contracts, and so it's important to see the buses. And then finally, so the last one, you have the contracts. Of course, you can enter the contracts manually, but because it's based on the cloud platform, you can just set them up. For example, if you have leaf, you will have like just as an automatic integration, maybe import both contexts autonomously. And then we also added a little bit of application, also automation directly inside the application. So for example, you can click pass, then here you can add some commands. And of course, this is not, let's say, nothing revolutionary, because we'll be, for example, in the afternoon, we will have the comments on the ground, and then in the evening, the pass will happen. So still saving you a little bit of time, and then it's going to also let's say, avoid just being too anxious, for example.
Okay, yeah, well, it saves time, but I would actually spend that money for creators. Maybe, you know, one person checking up stuff from time to time, you know, cost reduction, want to spend money on the next satellite. Yeah. So, yeah, can this FDS app actually work for me, or do I need to, you know, hire a developer, do something on top of it?
Yeah, so I'll show you like in the second class, we have commands. Now, I will show you later the way to add commands in an automated way. So I leave you the screen with empty commands, and now we will add them to the FDS. So back to the slide. So I mentioned we're going to talk about the MPS now. So MPS, what we're going to do is like we're going to reuse many of the same services from Leanspace. So for example, the digital models, we're using the same digital models, but this time we're going to add resources to them. So when you are creating a plan, a schedule, you can see how much the resources are using, and resources are like, for example, batteries, or they can be data storage. But before you can, let's say, plan, you need to know where your satellite is. You need to do plan around. So with Leanspace, we can provide you some plan around software. We can propagate your orbit. Very simple. We just do FGB for propagation. Here it is. So I don't know if that's enough for you.
Definitely not. You know, I know some work like expensive maneuvers, and you know, actually we're going to use the GPS data, so really, it's kind of, you know.
Okay, so that's fine. Because we get a lot of Leanspace, we provide you the cloud platform, and it can work. And of course, we are not experts in everything. So in this case, we're going to show you the integration, how easy it is to integrate with an external running software. And in this case, we're going to talk about the integration of Exotrail. And please welcome for the demo.
Thank you. So hi, my name is Kateryna. Yeah, okay, fine. So my name is Dewost. I'm a product manager at Exotrail. I'm the product manager of Space Tower, which is our flight dynamic system, which we will talk about. Maybe a quick word about Exotrail for those who don't know us. We are a space mobility company, so we develop all effect thrusters and satellites as well to provide in-orbit services. And so I'm just saying that so that you know that we operate these satellites with our Space Tower flight dynamic system. And so as operators ourselves, we understand the complexity of building a flight dynamic software that you can reuse through the different missions that you build. And at the same time adapt to the complexities of your specific collapse. And so that's the reason why we've developed Space Tower as a very modular solution on which you can reuse pre-built, pre-validated, and flight-proven modules. And so these functionalities cover typically everything you would need in flight dynamics for satellite operations. So typically we perform orbit determination from a various range of positioning data. So we have, as Kateryna mentioned, we can do that from GNSS telemetry, but also pretty much anything you can think of. Then we can also provide services to determine what will be the next orbital events that you need to find. So in the case of your Earth observation constellation, we can determine for you very precisely what will be the next stages over the areas of interest that you want to take pictures of, for instance. Then it's also obviously our core business to know our way about maneuvering satellites in space. And so we have a powerful maneuver planning and simulation module in which you can compute station keeping, orbit tracing, and so on. And so these are obviously including different kinds of propulsion, but especially we're good at computing low-thrust maneuvers for local satellites. And so then, of course, we also have collision avoidance capabilities. in which we're able to refine, for instance, collision data messages that we can receive through third-party providers. So I see that there are some of you in the group. So we can typically integrate with these kinds of solutions to improve the collision data message, the collision probability from the orbit determination. So this is how Space Tower typically integrates in a ground segment. So we are one brick of different modules that build the ground segment. So here in this case, you can see the US satellites in the sky. Then the antennas would be the ground segment as a service provider. So in our case, it's Leanspace here. And so then inside the mission control center, we interface with Leanspace mission control system and mission planning system. And so the flight dynamics system is tasked by those other components. And so this is very easy to do thanks to the API-first nature of Leanspace platform and Space Tower platform. Maybe I should mention as well that Space Tower software is cloud native, but it's deployed in a standardized environment, and so it can be deployed in the cloud on-site as well. And so in more details, how the integration is done is that Space Tower is basically a collection of microservices that run in orchestrated environments. And so these microservices are tasked, these are stateless microservices. So these are tasked by the Leanspace software that can, for instance, in the orbit determination use case, they will send the GNSS data that they receive from the satellites through the Leanspace network to Space Tower. And so Space Tower will process this data and return to an orbital state to give the orbital position of the satellites to the Leanspace platform, which will store this. And so from there on, Leanspace can perform different actions from their control center. They can request typically the computation of orbital events. They're also able to compute different maneuver plannings that Space Tower will be done. So these are typically time-stamped actions that you can convert to telecommands in the Leanspace platform as well. And of course, we can also, from the orbit determination, refine collision avoidance and collision data messages alerts that Leanspace will receive from their SSA partners. So that's typically how it would work. So that's what we're showing in this demo today.
Cool. Thank you. Thank you very much. If you have no questions for Exotrail, you can ask later, or you can listen later. So let's go back to our NPS. Now we have all the information that we need, and we can show you the example application with the NPS slide. As you see, we can show you how to leverage these services. So I can show you now you have the master timeline, and the idea is we got inverse activities from Exotrail, and of course we want to have mission into you take images, and then on the left you can see the master plan, you can see the resources that I mentioned before. Let's see how they behave according to our prediction activities, and then let's see the plan is going to end at the end of the day. So we need to update the So here we can go to the planning. We can go up the slide, and this is where you can have a graph, and you can see like we're going to create. We already set up in advance the activities that we want to perform, the numbers which come from Exotrail. We have some other experiments that we're performing, and the idea is that so this is basic capabilities from the NPS that you can find on the market. Now, the power is that this is all linked to the cloud, For example, when you are modeling the resources, the starting point is going to be the metrics that we showed you before, and it's coming directly from the MCS. Or activities are already marked comments in our activities and space in our MCS. So everything looks good for this plan. So we are going to complete the plan, check that everything is fine, no source code violated, and then we are going to commit this plan. So what is happening now? We are meeting the plan, and you can see the commands already been exported to the MCS. And of course, if you're using, let's say you're using an MPS in a different MCS, you might export, for example, the activities or your plan into CSV file or some kind of format that your MCS can read or the system can read. But because you're using one cloud platform, everything is already integrated. I don't need this export to MCS button. I can see the master plan has been updated. I can see my resources. And of course, what's still missing is that you need to communicate with the station. So
how do I communicate with the station? Because now I kind of have my plan. So how do I get it to my satellite?
So if you ask me, it's already going to be done.
Oh, really?
Next pass, it's going to be updated.
Really?
If you don't trust me, we can go back to the MCS.
I don't trust you so far.
I explained that. So we can go back to the MCS slide, and then suddenly there was no comments here, and now it's full of comments. And you can see all the comments from the plan has been pushed to the MCS, and then everything is going to be updated when the process is going to go. So you don't need to spend the afternoon or 10 minutes in the afternoon setting up the comments, especially because right here, I don't know how many we created, more than 105 comments, and you don't want to take them over. This is the power of the NPS and MCS.
Well, that looks really cool. So that's fine. But now my satellite is kind of orbiting, going well, and getting money from all the photos that I'm selling from my satellite.
Yeah, you're getting everything. What we did today, Roberto, is a fully integrated management center then. It's going to help you with your mission. You realize you didn't have to do too big work.
Mm-hmm.
You started doing testing, so you wouldn't want in a rush, like 3 months before launch, trying to set up an MCS in a halfway, or starting without an MPS and then setting it up later when you realize you're preparing for something higher and you want to stay up on the unit. So we built a platform, we built it for launch. Is that good?
No. Because I'm having more.
You're having more?
Yeah. But this is going well. I want more satellite, and maybe I'm actually planning to, to go to the ship's track and all that other interesting businesses.
Okay. So who else wants to scale this in this room? Hopefully all of you are launching your first satellite, and then you need to launch, I don't know, how many you promise your investors? 100, 300, 200 different missions. So let's see. So what we show you today is like starting with one mission. We show you the power of the full integrated concept, and fully integrated for testing and operations with one mission. So here you can see we did the cloud platform, we have the application leveraging, we have the operations, and then what everyone wants to go is to move to mission management. Because the next mission is going to probably be ballistic. You do something maybe with an IOD, and then you CubeSat, and then you launch a SmallSat. Or you need to launch your full constellation. The power of Leanspace is you can have one cloud-based platform. That is one with all the different missions that you have. You can have like multiple configurations running in parallel on one cloud-based solution. And then, of course, you can integrate multiple test benches, you can have multiple constellation providers, you need 3 or 4, you get so much data. So you have to, maybe you can wait a little bit for leave to keep deploying the antennas, but it might be that you still need more. And then you might need the latest AI data processing tool maybe. so that your guest will give you more money. AI on your next page. And of course, the question is how do you do it? So how would you be able to do it in Leanspace? So first of all, the solution is diverse. So we show you the architecture, you have the cloud-based platform. It's natively cloud-based, and then you can add out to the diverse missions because you can have, like, for example, network entity chain, parallel platform, and depending on the digital assets that you're using, it's going to go for one entity chain or the other. And then the versatility is also in attaching the platform to the applications. And then you can have different applications for different missions, or for different domains, or for different teams, but they're all going to use the same platform. And then it's easy to integrate. So you can have all the third-party applications. You might actually need to build something in-house, specific for the mission, or anything. So you build your tool, and then it's easy to integrate with Leanspace. And then finally, it's scale. Because when you have, let's say, many people saying, oh, we are cloud ready, but it means they just have to swing to the container. Once we are cloud native, we use all the power that is available, for example, for AWS, and the resources are going to scale autonomously. So you don't have to worry about, okay, if I need to assign a little bit more out to my local container, that's not going to happen with this system. You're going to have, for example, lambdas. I don't know what they are. I don't know either, but I'm thinking about that. They scale automatically, so if you're sending more comments, the lambda will utilize more resources. In this way, you're able to scale. You can use, for example, so you are able to scale for constellations, for example, but also for missions. And in this way, you'll be able to serve all the customers and get the device.